Well, it looks like we're live again at CNBT 1311 land. All right, this will be video 3 in chapter 11. All right, water supply. We are going to go to war over water, in my opinion, in not too many years. Lake Powell is down. We have water supply problems out west due to the years of drought. When I was a wastewater treatment engineer, I did 3 of the world's largest wastewater treatment plants. 2 of them are located here in Houston area, and we're talking 150 to 225 million gallons a day of wastewater that's treated. And we dump the effluent, the treated wastewater, back into the bayous at the rate of 100 to 225 to 250 million gallons a day. That water is just almost drinkable. It's cleaner than the water going into the Federal Road water treatment plant. Back in the 70s, I tried to get the city of Houston to allow us to do a final polishing of the effluent and then reuse that water that we spent all that money to treat and put it back in the water system. The politicians went stupid. They thought I had lost my mind. You want us to tell the people of Houston that we're going to have them drink their toilet water? No, we are going to tell them that that water is cleaner than the water coming out of the Federal Road water treatment plant. It's potable water. It's perfectly drinkable. It meets all the federal and state requirements. There is nothing wrong with it. It is treated. It's no different than taking the water out of the bayou and running it through a water treatment plant. But all them politicians wouldn't have it. All them people would go crazy. Well, guess what? We're screaming for water. Gulf Coast Subsidence District has pretty much put the kibosh on groundwater because of subsidence. State of Texas takes a very keen eye on new water well permits. If you've got an existing water well for your property and you didn't get it grandfathered in, you could be in potential problems. But water is a big, big deal. We fought cattle wars in the 1800s over water rights in this country. Sweetwater, Texas got its name because some cowboys were looking for some lost cattle in the 1800s up on the Llano Escondido, and were about to die of thirst. Then they came upon a low spot in the creeks. Now, Comanches knew where the water was. They found it, and they could water their cattle and their horses. And I'm not sure the water was real sweet, but when you're dying of thirst, any water is sweet water. So Sweetwater, Texas got its name from cowboys looking for lost cattle. There's no extra charge for that, by the way. All right, water supply systems. Water is utilized in the building in the following ways. Well, no kidding. It's consumed by drinking, cooking, and washing. HVAC systems sometimes circulate water for heating and cooling depending on the type of system, and for fire protection. We ain't even got to fire protection yet. That is a whole specialized deal, and we'll talk about that later for fire protection. The total operating head equals your service pressure minus any friction loss in your piping, and we call your pumping head. Let's say you got a 2-story building. Let's say you got a 50-story building. How are you going to get that water pumped up there? You're going to have surplus water pumps to get that water pressure up there, right? That's water head, pressure head, okay? We call it head. Don't go call HR and say I'm speaking nasty words, but that's the engineering term for the water pressure given the height, okay? If you have a water tank up here, and this is water, and you're containing, here's a wall. I'd fire me if I drew a wall like that in AutoCAD. and I've got a valve. I've got a valve here. That valve has to be rated for the head of water above it, the pressure, okay? And if I'm trying to get the water from down here to up here, it's the same deal, okay? Same thing. And the same with a water well. Now, that 300 acres I had for a long time out west, we had a water well that was grandfathered in, and it was a submersible pump in a casing. And you have to have sand screen in there because you don't want it to collapse and sand up. And that submersible pump was a 240 volt single phase motor, and went to a pressurized tank that was sitting out here. So the tanks can be sitting out here in what's commonly known in the rural areas as a pump house. And you build an insulated structure around them so when it gets cold, in most of these pump houses, if they're designed right, you can pick it up with a tractor and lift it off of here, so you can bring a service truck in here to yank that pump out and service the well if need be. All right, because this stuff will freeze if you're not careful. These tanks will have an air bladder in them to build up pressure. The air bladder will be up here on top, and they'll have regulators and a pressure gauge. All right. The pressure tank does just what it says. It maintains the service pressure. All right, and it does require electrical power. And this is a no-duh, a fuse disconnect switch. Really? Okay, yeah, you have to have a disconnect. We'll talk more about disconnects later on. The well should be located at least 100 feet away from buildings, sewers, septic tanks, and sewage disposal fields. That's your drain field from your septic tank or your aeration tank. We'll talk more about sewage in a little bit. It may be crap to you, but it used to be my bread and butter. You got to be able to service these and maybe even change the well casings out. You have to check your codes, your applicable codes. This will be governed by the county, the state, the health department, and a plethora of other people to get a permit to go sink a water well. All right. Out in Tomball, the old Humble field, they had a big chemical spill back in the 50s, and some very bad stuff, some very bad juju chemicals leached into the water table. And that water table runs from Tomball down towards the city of Houston, and it gains so many feet per year. And that was the second big push by the Gulf Coast Subsidence District back in the 70s and early 80s to get everybody off of groundwater because of the contaminants in the groundwater. Now, if you can go down thousands of feet to an aquifer, like the Balcones Aquifer, which is getting low, by the way, like in San Antonio, you've got limestone above it. So the subsurface groundwater does not mitigate into the aquifer, but they maintain and test that aquifer periodically, and it is getting lower. The aquifer comes from thousands and thousands and thousands and thousands of years ago from the glacier melt-off. Sometimes the aquifers get recharged with heavy rain and flooding, and it filters down through the limestone, which helps filter it. Okay. Now, water can also be supplied by a municipal public system that is governed by the regulation of the state of Texas, here in Texas and in other states, to have a regulated and certified water system. Let's see, what does he say about well water? If the source is deep enough, it's usually pure, cool, and free of discoloration and taste or odor. That can be and cannot be. Sometimes you'll get water that has a very sulfur taste to it because you've got naturally occurring gases in the ground. So you got to be careful how deep you punch that well. Actually, the oil fields in Saudi Arabia were discovered because they were trying to drill water wells, and they punched into the oil field. This was many years ago. All right, and it's got to have the right quantity, which is Q in civil engineering terms, the volume of water flow, and at the proper flow rate, which is a part of your QR, and the pressure and temperature to satisfy all the requirements. Okay, it's got to be free of bacteria, and it's got to be palatable. In other words, it's got to taste okay. So you may have to treat the water. You may have to have a water treatment system in here. Maybe the water's too hard. Or up there around Giddings, some of that water coming out of the ground is hot. You got a high level of geothermal in there. So some of the older hotels, their hot water was geothermal hot water. So you may have to have a water polishing plant in here, either an RO unit, a reverse osmosis, cartridges, or a water softener where you're using a potassium chloride to soften the water, to treat it. I think that's enough of that. Now, if you have a municipal system, I apologize for that dog. If you have a municipal system, then the municipal system will be through a mud district or a water district that is a taxable entity in the state of Texas. That's why the bigger ones have their own police department, because they are a taxable entity, and they're allowed to have their own police force to secure their water systems and provide security for the service area in which they service. A water main is a big pipe that's in the ground. The regional water district in what's its official name? Let me look at my water bill. Yeah, North Harris County Regional Water Authority. Okay, is what it's called. They're pulling water from the lakes around Houston and sending it to water treatment plants like Federal Road, and supplying potable water. And so what you do is you come in and you do a hot tap off the water main. There's a special tapping tool that's used, and there'll be a shut-off valve somewhere in the area where they do a tap. They bring a service line in to a shut-off, and the shut-off could be incorporated into the what he's calling a curb box, but it's really a water meter. This is the box, okay? What he's calling this is the curb box. That's the curb box. The water meter and shut-off valve for the meter sets in here. This is the service side of the meter. So everything from here over to here belongs to the water district. So if there is a leak from the meter back to this way, that belongs to the water district. They pay for the water. If the leak is on your side of the meter, well, I actually drew this wrong. Good God Almighty. Okay. Okay. We'll just, how about picking up, there you go. From the meter back belongs to the water district. If it's from there to here, if the break's anywhere in here, that you pay for the water that's leaking out, and you pay for the repair in here. Okay. Now this is called the service pipe, because this is the service side of the meter. Every building, every residence needs to have a shut off where you can get to it, because sometimes getting out here with a shut off wrench tool I welded up several. I've got one that I'll shut that meter off to my house with no problem at all. But I also have a disconnect outside the house. Now this is going into a basement. We don't have basements down here, so they'll bring up and they'll go through the wall. And you need to have shut off in here someplace. And I'm a big proponent for quarter turn ball valves, full port ball valves. I don't like those globe valves, but I digress. Okay. Sometimes they'll have a water tank up on the building if it's a high-rise building, um, and they'll have a pump down here in the basement of the building. They'll come from the water supply, and it will pump it up and fill up that tank. And then you have gravity head. Let's just say this is a 50-story building. Well, it's kind of exaggerated. Let's just say it's a 20-story building. Then you got 20 feet ahead. From there, 20 stories ahead down to here. Now, that means you're going to have lower pressure here than you would down here. So you have to have pressure regulating valves so that you can have constant pressure at each one of these outlets. Okay, if water is supplied at 50 psi, upfeed distribution is feasible for a low-rise building up to 6 stories. Okay, for taller buildings or where the water service pressure is insufficient to maintain adequate fixture service. Now, what a fixture service is means the flow rate and the pressure at the fixture, whether it's the toilet or the sink. Water's pumped up to an elevated or rooftop storage tank for gravity downfeed. And it can also be used as for fire protection, assuming your water tank has enough volume for fire suppression. That has to go back to your fire protection company that is certified by the state to do all the fire protection building code requirements and the engineering and everything else. There must be sufficient pressure at each fixture to ensure its satisfactory operation. Fixture pressure requirements vary from 5 to 30 psi. Too much pressure is undesirable, just like insufficient pressure is. Water supply pipes are therefore sized to use up the differential between the service pressure, allowing for the pressure loss due to a vertical lift or hydraulic friction in the pipe. This is all engineering stuff, okay? And then you have to have pressure reducers. I've already said that. Because you can imagine if this is a 6-story building that down here, these are going to have more pressure on them without pressure regulators than these up here would, right? Because this is a shorter distance. Less head, therefore it's less pressure. This has greater head, so it's got more pressure. So you have to balance out your pressure regulators, and that's your building engineers, facilities engineers, to make sure those pressure regulators don't get all gunked up and they stay adjusted. And your mechanical engineer who does the plumbing for you, the MEP, mechanical, electrical, and plumbing. And there are companies that specialize in MEP, mechanical, electrical, and plumbing. And we'll see how many of y'all actually watch the video. MEP, mechanical, electrical, and plumbing. And there are companies that have electrical engineers and mechanical engineers that do the HVAC and the plumbing. All right. Obviously, any exterior hose bib should be frost-proof, frozen-proof, freeze-proof, and insulated, with the ability to be insulated. We all had to go through that in the last little freeze, okay? Here, he talks about the water softener, okay? It removes calcium and magnesium salts from hard water by ion exchange. Hard water can clog your pipes, corrode your boilers, mess up your water heater. You know, I didn't say hot water heater, I said water heater. I hear he uses just water heaters. I love it. Okay. Can be gas or electric. And in the process of heating that water, if you've got too many minerals in that water, it'll calcify up your water heater. So what started out as a 100-gallon or a 50-gallon water heater over the life cycle will not be 50 gallons or 100 gallons. And then getting this thing to drain, that valve to drain, can be problematic. A good installation has a recirculating pump. There'll be a recirculating pump in the system that's on a timer that periodically recirculates the water throughout. Well, the pump's going the wrong direction, you goober. Oh my God. You put the pump in the recirculating deal like this. Oh my goodness. You need to pay attention. Let's get rid of that. All right. And it keeps the water to flow through the system at a periodic time interval, so that if you're far away from the water heater or your boiler room, you don't have to waste so much cold water waiting for it to get hot. All right. Let's move on. And we've already talked about solar water heaters. It works when the sun's out. Now, here's something we hadn't talked about, and that's on-demand water heaters. These can be problematic. The best use is under sink. Takes electricity, and so when you turn them on, they immediately come on. Now, there are some whole house on-demand water heaters that are natural gas, and you'll see them on the outside of the buildings. In that last giant freeze we had a couple of years ago, a lot of people with those on-demand water heater systems, they froze up because there's a weak link in them. There's some plastic fittings inside there that froze and broke, and the whole house was out of hot water. All right. Pressure relief valves are required on all water heaters, because a water heater is a boiler, and the water heaters are regulated by building codes, UL codes, and the Boiler Manufacturers Association. And you've got to watch the temperature of the water. You want to set your water heater from 120 to 140 degrees Fahrenheit for safety reasons. And you get much hotter than that, and you'll be cooking your skin. 140 degree water is pretty hot. All right. Water supply systems. He's going here talking about fixture demands. Individual demand or fixture demand. Okay. So let's say you're designing a structure, and you're going to have bathtubs and showers and lavatories, toilets. Is it a tank type toilet? Is it a flush valve? Urinals, kitchen sink, a clothes washer, service sink, a hose bib. This is the theoretical. Notice I use the term theoretical. Load in fixture units. Now, when civil engineers are sizing those service pipes to supply water into a subdivision, they affix a certain amount of fixture units per household. And but theoretically, for the sake of this discussion, a bathtub is 2 to 4 fixture units. And I would certainly err on the high side. I would err on the high side. This is a tank type, and this is a flush valve toilet. Okay. And this is another rule of thumb. Your mileage is going to vary. The minimum supply pipe in inches for these things. All right. You'll notice that a flush valve, which is what you'll usually find in a commercial structure, well, you will, is always a 1-inch pipe, whereas your conventional toilet with the tank is 3/8. and so forth. But don't be surprised if your mileage varies. But on these fixture units, I would err on the high side of these. Check your local code. Check your local code. They may require you to have more fixture units. All right. Estimating your total demand. All right. And your total demand in gallons per minute. Okay. So, again, check your code. And because the last thing you want is to design a structure and have a poor water system. You'll get a bad name for yourself. Now, water supply lines, they can be copper, galvanized steel, they can be plastic, they can be PEX. We've gone, the technology has increased such that the PEX units we're getting today, the PEX pipes, are not those garbage things that caused that great lawsuit back in the early 70s. In fact, there's some places up in Colorado they use almost all PEX because the pipe doesn't explode when it freezes. PEX is very flexible. And the fittings for PEX now have gotten really good. The swedge fittings. You can research that through Google. And they're sized according to the number and types of plumbing fixtures served with the pressure losses, just like a high-rise building. Okay, and it's the number of gallons per minute is what we need to estimate. The water supply system can usually be accommodated within floor and wall construction spaces depending on how thick your wall is. It should be coordinated with the building structure and other systems and your building code and your drainage system. Okay, don't expect to get an 8-inch sanitary sewer line dropped from the second floor down through a conventional 2x4 wall. It won't fit. These things should be supported. He uses a rule of thumb 6 to 10. You check your building code. You check your building code. In some areas, they need to be insulated and wrapped with heat tape. Heat tape is nothing but a heat generating wrap that goes around a pipe to keep it warm under the insulation during freezing conditions. Cold water pipes need to be insulated for condensation and to prevent heat flow into the water. Okay. Down here with the high humidity we have, condensation is a big deal. After the last freeze, we had some water dripping from a fur down over the kitchen sink, and it was condensation that was built up in the uninsulated fur down. Hot water pipes to be insulated against heat loss. You're spending all that money to heat the water. You certainly want to not let it escape like they do in these residential houses. In very cold climates, water pipes in exterior walls in unheated buildings can freeze and rupture. So you need to take this into consideration. Now the benefit with sprayed in foam is you can run the water pipe in a wall. Let's assume that's a sill plate. Y'all all know what a sill plate is. There's a stud coming up. Here's an exterior skin, exterior. Let's go and get a different color. Let's say you're running your water pipe to the center of that wall. whether it's wood or light gauge steel, and then come in after you get all this done and spray that foam in here and encapsulate all that after you've water tested it, after you've pressure tested it, and that way you're not trying to stuff fiberglass batting back in here. Does that make sense? I think it does. Let's go back over here to our normal color red. All right. Okay. Here's a typical sink. We've already seen this. This is a top-mounted sink. Potable water comes in. This is for water hammer. It's the concussion and banging noise that can occur when a volume of water moving in a pipe is shut off abruptly. Air chambers are installed at fixture branches to prevent water hammer. You'll see those cylinders in a high-rise building. And they also sell the little water hammer cartridges that you can put on here. But if you'll just stick a riser pipe, this riser pipe is going to have air in it before you charge the system with water. And so you've just essentially built you an air column in here. So your water supply will come through here. It's pressurized. It'll go up through there. It'll rise enough, depending on the pressure in the system, to compress the air in this pipe column, and that will also serve as a hammer cartridge. Good plumber can explain all that to you. All right. Every fixture run out needs a shut-off valve. Every single one of them. And I hate these valves. These are crummy valves. They're usually nylon stemmed. Again, I'm a proponent for a quarter turn ball valve, but I'm an engineer and a geek, so I don't know what to tell you. All right. The fixture run out is how far away from the wall this thing runs. Okay, so that's terminology. This is a branch supply line. And yes, it should be placed on the warm side of the wall, or run dead center in the wall, and you spray that foam in behind it. As you can tell, I'm a proponent for spraying foam insulation because it serves as a vapor barrier, a good one, closed cell foam. And I put videos up about that in previous chapters. Now we're in fire protection system. It's probably time to check on our time here. Oh, we're at 32. All right, fine. Fire protection, fire alarm, and fire protection systems. All right. This is a typical sprinkler head. These things have a fusible link in them. So let's just say we have a fire load here. Let's say we got a fire load. Oh no, we're burning alive. Okay, heat theoretically builds up, and there's a little glass rod in here, and that thing will break. And when it does, it drops this valve plug down, and then the fire pressure, which is separate from your potable supply line system, unless you've got a huge enough tank and the code will allow you to poach off your water reservoir. You'll see in some industrial buildings, they'll have a water tank, a big one on the outside. That is strictly for fire protection. It'll be sitting on the ground, okay? And that all has to go back to the NFPA's Life Safety Code and recommendations. That is the National Fire Protection Association, okay? Fire protection systems that are engineered and designed are a special system. They will have a connection on the outside for your fire department, and they may have surge pumps in there that are strictly for fire pumps. We have those at Cypress Center, this is a whole specialty discipline, okay? For public safety, building codes often require fire sprinkler systems. That's your building code. You've got to check your building codes. All right. The fire marshal will come out and inspect these systems periodically. The companies that design these fire suppression systems are registered, licensed by the state, and they're inspected. We have some terminology over here. We got wet pipe systems that contain water at sufficient pressure to provide an immediately and continuous discharge. A dry pipe system doesn't have water in it, but it's pressurized, contains pressurized air that's released when a sprinkler head opens in the event of a fire, allowing water to flow through the piping out the open nozzle. The dry pipe systems are obviously in areas that are susceptible to hard freezing. A pre-action system, there are dry pipe sprinkler systems through which water flow is controlled by a valve operated by the fire protection devices. And these are more sensitive to those in the sprinkler heads. Okay, so you may have electronic fire monitors throughout the building, these sprinkler heads do not have the fusible link in them, and if the unfortunate thing happens and it sets off, it'll charge these pumps and it will charge the piping system to then start sprinkling water. Okay. A deluge systems, they have sprinkler heads open at all times, through which water flow is controlled by a valve operated by a heat, smoke, or a flame sensing device. Okay. And that goes back to the pre-action systems. Pre-action systems can also be argued that they are a deluge system because they're dry until you need to charge the system with water. The problem with that is time delay. It's the time differential between when the fire starts up here to get your standpipe charged with water and get all this charged. Okay, so if this floor doesn't have fire on it, they got to have control valves in an open system to keep dumping water, because the water is going to go at the lowest point. So as soon as this gets up, you're going to have water here. You'll have less water there, less water there, and less water there. Wet standpipes contain water under pressure and fitted with fire hoses for emergency use on the floor. That's a standpipe. That's a wet standpipe. You have dry standpipes that are just like the dry system. They're waiting to be charged. Okay, contain no water and are used by the fire department to connect fire hoses to a fire hydrant or a pumper truck. And that's hoping they get there in time and can get the hose off the fire suppression truck. The fire suppression team can lay that hose out to a fire hydrant that is close enough to get that done, or hook up a pumper truck. Okay. Dry standpipes, you have a time delay because you got to get the crew in there to hook it up and charge it, as opposed to a wet standpipe. We already talked about fire pumps. They're inspected when the fire marshal comes out and inspects the fire suppression system, just like your boiler system is inspected by state boiler inspectors. All right. This is a Siamese pipe fitting because of a Siamese twin thing, right? You got two fittings on there, okay? It's installed close to the ground on the exterior of a building, and they're providing two or more connections through which the fire department can pump water to a standpipe or a sprinkler system, okay, if need be. All right. So you'd have a Siamese connection on a dry standpipe. If you have a wet standpipe, then that's going to be tied back to this. All right. And there may be two systems in a building. Your mileage may vary. Okay. But all of this has got to be engineered and sized by a fire protection engineering company that specializes in this. If you ever see the suspended ceilings dropped out at the Cypress Center, if they go up and do maintenance, you'll see that the fire sprinkling system is separate from the chilled or hot water system or the potable water system. Now, they may be connected to the main water main, but they're on a separate system inside the building. All right, plumbing fixtures. Where are we at on time? Let's check our time. Oh, we're at 40 minutes. Plumbing fixtures. Let me check the 5th edition to make sure that how much plumbing fixtures, how many pages is. Yeah, let's go to plumbing fixtures, and then we'll pick up sanitary on the next video. Again, this is a top-mounted sink. Potable water comes in. That's your water hammer column. This is your, what did we say that was? That's your tailpipe, wall pipe going out through the wall. This is your P-trap. This is your J-bend. Oh, I lost my mind. I've lost my mind. Some up here. Oh my goodness. I've lost my mind. I love it. I love it. Oh my gosh. There we go. All right, this is the J-bend. This is the tailpiece. This is the wall tube, right? Okay. And this is a wastewater out. All right, let's go back down. And this is the weir line. That's called the weir line. Remember? This whole thing's a P-trap. Oh my goodness. The whole thing's P-trap. Cover a lot of real estate. We're covering a lot of real estate. Here we go. All right. Okay. So we got our definitions. So this whole thing's a P-trap. That's the wall pipe, tailpipe. This is your sewer out. Now, this is the weir. This is a weir line, just like in a wastewater treatment plant. Okay. On a clarifier. Water comes up, slows across the weir. Sometimes the weirs are flat, sometimes they're V-notch. It slows the water flow down into the collection channel, which then goes out for further treatment. All right. So what this does is, like I previously stated at the beginning of this video, is it seals the sewer gas. The hydrogen sulfide, H2S. All right. That's the natural gas, the sour, rotten egg smell coming out of sewer gases. If you've got that smell in your house, then you got a P-trap that's dry somewhere. All right. And you need to recharge it. Just run water in here, and it'll charge that P-trap. Now, there's several levels of H2S. H2S in oil well drilling, that's such a high concentration of parts per million, you don't smell it. And that's the dangerous part, when you can't smell it. People start dropping out and dying like flies. In sanitary sewer systems, they used to be made out of reinforced concrete pipe. The gravity sewers, so you'd have the sewage in here, the gas, the hydrogen sulfide rises and collects on the moisture, the condensation at the top of the concrete pipe. And when the hydrogen sulfide, the H2S, mixes with H2O, it turns into sulfuric acid, H2SO4. H2SO4. Now, it's not chemistry class, so don't worry about it. I'm not going to ask you that question. But hydrogen sulfide mixed with water turns into H2SO4, sulfuric acid. And that acid eats the calcium carbonate out of the concrete. So then you have exposed aggregate and rebar, and then the rebar rust, and the top of the pipe collapses in, and then you have all that dirt flowing in with sanitary sewer. Now, they don't use RCP anymore, reinforced concrete pipe, for sewers. At least they don't in this country. We've got technology now, high-density polyethylene, super corrosive sewers used to be made out of high-baked clay pipe, which is expensive, belt and spigot. Some of the best sewer pipe is a Spiralite by Chevron, I put in miles of that in wastewater treatment plants, 12-foot diameter things, and then encase them in concrete. And it's thick, high-density polyethylene with spiral reinforcement on the outside, and that sewer gas will not eat that at all. I use that in that 6-mile trench, suction trench down in the Philippines. That's some good pipe. We had concrete collars on it to sink it, but that's not even part of this course. I don't even know why I'm bringing it up. All right, here's a toilet. They have a P-trap cast in to the toilet itself, and it has the same thing. Here's your weir line. That's your weir line. The level in your toilet. On the back side of the P-trap is your weir. This is a floor outlet toilet, and this is a back. This is a wall outlet or a back outlet toilet. All right, and these traps, like I said, are cast in with the ceramic bowl of the water closet. Okay, or the toilet. I guess water closet is the more genteel name for a toilet. All right. Problem with wall hung toilets is you got to have a structurally sound wall and fit them to it. If not, they'll tend to cantilever out, because this is a cantilever. Remember our little statics deal? You know, big old beer drinking Bubba sets in here. Here's a little pumpkin head. Okay, big old beer belly. All right, here's this. Okay, all this weight is going to make this thing want to rotate. Okay. All right. Kind of looks like an alien head. Oh well. All right. Most of your toilets in your residences are floor mounted, and then underneath here they'll have a P-trap. Okay. There will be also a fixture coming down. Well, they won't have a P-trap here for the toilet because it's in the toilet itself. But then you'll have a 90 that comes out. Now, a note on plumbing fixtures. To turn a 90 for a gravity flow, they don't use a 90 like you would a typical 90 for a pressure pipe. The plumber will use 245s to make that 90. So you have a smooth, long elbow flow with 245s. Let's see if I can draw that. And then coming up, we'll make a piece, and then you've got that 45. So that makes a flowable, more flowable for the solids in a gravity pressure pipe system, or a gravity flow system. All right. All right. And you've probably seen those wet wipes where they advertise, this is toilet safe and they're flushable. Just because they're flushable doesn't mean they're flowable. Doesn't mean they'll flow down through the sewer line without eventually clogging stuff up. You know, flushable and flowable are two different things in plumbing world. All right, no extra charge for that. Here's a typical bathtub. All right. A drum trap is a cylindrical trap closed on the bottom and having a cover plate for access, commonly installed on the drain line from a bathtub. There'll also be a P-trap in here by code. You can't rely on that to be your P-trap. All right. Now, theoretically, all of this can be a JP trap, right? Because your water level is going to come in here, and you'll have a water trap line in here. So theoretically, this does serve as a P-trap. All right. Some plumbers will come in and actually put a shallow P-box P-trap in on these things because there's not room to put one of these. All right. And this is your overflow for your bathtub. Got to have overflow, right? Okay. All right. But this would be your weir line. This would be your water line that would be trapped in this system. Okay. Then on the back side of this would be the outflow. All right, let's move on. Now we're into plumb fixtures, on the sanitary drain systems, and I think I said that's where we were going to, yeah, let's go ahead and stop this video here and we'll get into sanitary. All right. Oh yeah, we're at 50. Let's go ahead and stop this here. We'll